Imagine a city where Earth rises on the horizon instead of the sun. A city where gravity is just a fraction of what you're used to, allowing you to leap higher and carry more with ease. Imagine streets bustling not with cars, but with rovers and spacesuits. Domes of gleaming glass housing entire communities beneath an eternal black sky dotted with stars. This isn't science fiction anymore, but rather a vision of humanity's next frontier, a city on the moon. What would it take to build it? How would we survive the moon's extreme environment? And most importantly, what does life on the moon mean for our future? Get yourself comfy, because today we're digging in on a journey that's literally out of this world. The moon, Earth's only natural satellite, is just 384,400 kilometers, about 239,000 miles away. That's a cosmic stone's throw compared to Mars or other planets. It's an ideal stepping stone for interplanetary exploration and could serve as a launchpad for missions deeper into space. Plus, the moon is rich in resources like helium-3, a potential fuel for nuclear fusion, and rare earth metals that could revolutionize technology back on Earth. But there's a catch. The moon's environment is hostile. Its surface temperature swings wildly, from a scorching 127 degrees Celsius, 260 degrees Fahrenheit in the sun, to a freezing negative 173 degrees Celsius, negative 280 degrees Fahrenheit in the dark. There's no atmosphere to breathe, and the surface is constantly bombarded by micrometeoroids and cosmic radiation. So how do we even begin to plan a city here? The first challenge is finding the perfect spot. Scientists agree that the moon's polar regions hold the most promise. That's because craters near the poles, like the Shackleton crater at the South Pole, are home to something incredibly valuable: water ice. This ice can be mined and processed into drinkable water, breathable oxygen, and even hydrogen for fuel. Additionally, the poles receive almost continuous sunlight, making them ideal for solar power generation. Once we've picked our spot, we'll need to clear the area of large rocks and prepare the regolith, the moon's dusty surface material, for construction. This is no small feat. The regolith is sharp and sticky, capable of damaging equipment and posing health risks. Specialized robotic bulldozers and excavators, controlled remotely from Earth or lunar habitats, will do the heavy lifting. The first structures to go up will be temporary shelters and labs. These will likely be inflatable habitats coated with a layer of regolith for protection against radiation and micrometeoroids. Eventually, permanent buildings will be constructed using materials found on the moon itself. One promising method is 3D printing with lunar regolith, which can be turned into a concrete-like material. NASA and ESA are already experimenting with this technology. Power will come from solar panels strategically placed to capture the maximum amount of sunlight. Excess energy will be stored in batteries or fuel cells for use during the moon's 2-week-long nights. Communication will rely on satellites orbiting the moon, ensuring a constant link with Earth. Transportation within the city will require rovers and autonomous vehicles. Roads will be smoothed out using compacted regolith, and underground tunnels may be built to protect travelers from radiation and temperature extremes. Ensuring human survival on the moon is one of the most challenging aspects of establishing a permanent presence there. Life support systems must be capable of delivering breathable air, clean water, and a sustainable food supply, all within a closed-loop system. For breathable air, oxygen can be produced by extracting it from water ice or directly from the regolith through electrolysis. The carbon dioxide exhaled by residents will be captured and processed, converting it back into oxygen to maintain a consistent supply. Water management is equally critical. Every drop of water will be recycled to maximize efficiency. Advanced filtration systems will process urine, sweat, and even moisture from the air, ensuring nothing is wasted. Lunar ice deposits will serve as an additional resource to supplement the recycling systems. Food production will also transition towards self-sufficiency. While initial supplies may rely on shipments from Earth, lunar agriculture will focus on hydroponic and aeroponic techniques. These methods use nutrient-rich solutions or mist to grow crops, eliminating the need for soil. Plants like lettuce, potatoes, and soybeans, which are already successfully cultivated in space, will become dietary staples for Moon residents, providing the foundation for a sustainable food system. Life on the Moon presents a series of unique challenges that must be carefully addressed to ensure a sustainable and safe existence. One major concern is radiation. Unlike Earth, the Moon lacks an atmosphere or magnetic field to shield its surface from high levels of cosmic radiation. To mitigate this, buildings will need to be constructed with thick walls made of regolith or other radiation-resistant materials. Additionally, underground habitats could offer enhanced protection, creating a safer living environment for residents. Another significant challenge is microgravity. With only 1/6 of Earth's gravity, the Moon's reduced gravitational pull may initially seem exciting, but poses long-term health risks such as muscle atrophy and bone density loss. To counteract these effects, residents will need access to specialized gyms equipped for regular exercise routines designed to maintain physical health. Psychological well-being is also a crucial factor. The isolation and stark conditions of lunar life could negatively impact mental health. To combat this, virtual reality systems and entertainment centers will be important tools to provide stimulation and relaxation. Regular communication with loved ones on Earth will further help to maintain a sense of connection and emotional balance for those living in such an extreme and distant environment. A lunar city won't just be a scientific outpost. Rather, it would need an economy to sustain itself. Mining operations could extract valuable resources like helium-3 and rare earth metals, which would be transported back to Earth. Tourism is another possibility, offering a once-in-a-lifetime experience for those wealthy enough to afford the trip. Governance is another critical question. Who will own the Moon? Currently, international treaties like the Outer Space Treaty of 1967 prohibit any nation from claiming celestial bodies. However, as private companies get involved, new laws and agreements will be necessary to ensure fair use of resources and peaceful coexistence. What would daily life be like for the residents of our lunar city? Imagine this. You wake up in a comfortable habitat, where the view outside your window reveals Earth suspended in the endless black of space. Inside, the artificial gravity in your living quarters makes movement feel surprisingly close to what you're used to back home. After enjoying breakfast, you prepare for the day ahead. The work of a scientist might involve studying the Moon's geological mysteries or conducting cutting-edge experiments in a high-tech laboratory. Alternatively, a technician's focus might be on maintaining the city's life support systems or ensuring the smooth operation of mining activities vital to the settlement's sustainability. During your leisure time, the Moon offers a variety of unique activities. You could take a rover out to explore the alien terrain, immersing yourself in the stark beauty of the lunar surface. Alternatively, you might choose to unwind in the city's virtual reality arcade or spend time in a communal space designed to encourage socializing and foster a sense of community. When it's time to eat, meals combine fresh vegetables grown hydroponically with packaged foods transported from Earth. On special occasions, the menu might feature rare treats made from imported ingredients, adding a touch of earthly comfort to life on the Moon. A lunar city would be a proving ground for technologies and systems that could one day support colonies on Mars and beyond. It would also unite humanity in a common goal, inspiring generations to dream big and reach for the stars. One day, the Moon may no longer be a distant dream, but a place where humanity thrives. Think of the moon as a city alive with innovation, resilience, and hope. The road to get there won't be easy, but every great achievement in history began with a single, bold step. Imagine the day when lunar pioneers call it home, when our next leap forward becomes a reality. If you enjoyed this journey to the moon, don't forget to like this video and subscribe for more adventures into the unknown. Together, we'll continue to explore the incredible possibilities of our universe.